So welcome to this video. This is the second part of our series on transcendental functions, and we're proceeding with logarithmic differentiation. So from the last video, we discussed what logarithmic differentiation is, and we solved this example that is right here. Y is equal to x power 5 over 1 minus 10x, and the square root of x squared plus 2. So we solved this, and I explained step by step and how all these come into play. And so we proceeded up to a point where we found this as our final result. Mind you, you can get this document that I'm using from SlideShare. The link is in the description of this video. So today we're going to proceed with some more forms that of equations that can be solved using logarithmic differentiation. So as we proceed, one of the forms that we can see that it can be harder for us to simplify is the form where functions are raised to other functions. So from the previous example that we did in the previous video, we can exactly see that doing logarithmic differentiation simplifies the process of differentiating some complicated equations. So in this video, we're talking about some of the forms. So from the where I put a box on equation 5, we know that we have been given if y is equal to f of x raised to g of x, then we're going to add natural logarithms both sides as we did in the previous video. So we're going to have natural log of y being equal to natural log of f of x raised to the g of xth power, which is the same as g of x times natural log of f of x using the laws of natural logarithms, or simply the laws of logarithms. So if you apply the implicit differentiation on that, just as we did in the previous example, you're going to see that this will even be simpler using logarithmic differentiation than some of the ways that we might think of. So that's what we're going to be doing in this video. So for example, if you look at this example, they are saying differentiate y is equal to x to the xth power. So firstly, we can just introduce the natural logarithms both sides. But we should know that the power rule won't work here. That's because for the power rule to work, x must be raised to a constant power. So x power n, where n is a constant, we can apply the power rule. But in this case, the power rule can't be applied. And also the exponential differentiation of a power x, where we can have a power x natural log of a, can also not work because the base is not a constant. In that case, both the base and the power are variables. So let's introduce natural logarithms both sides. In this case, we're going to have natural log of y to be equal to x natural log of x. From here, we are going to see that if we differentiate both sides using using the chain rule as well as the implicit differentiation, we're going to have now 1 over y times dy dx being equal to 1, which is the integral, the derivative of x times natural log of x plus x times 1 over x, which is the natural log, the derivative of natural log of x. So we are using product rule on the other side because we're having two functions, x and natural log of x, that are multiplying each other, which simplifies to natural log of x plus 1. If we multiply by y both sides, as we did in the previous example, we get the final answer as dy dx being equal to natural log of x plus 1 times y, which is x power x. So that's one of the things that we can do if you are having functions that are raised to the other functions. In this case, we can take x, the base, as f of x, and the other x, the power, as g of x. We're going to have the first example in our second part of different forms that we can have that can be solved using the logarithmic differentiation. So this is the second example from the previous video. So we are having given y is equal to 1 minus 3x and raised to the power cos of x. We should find dy dx. So this is very easy. What you have to do here is to introduce natural logarithms both sides. So you're going to have the natural log of y to be equal to the natural log of 1 minus 3x raised to cos of x. Now Using the laws of logarithms, this cos x is a power, that means can be multiplied uh, to the natural logarithm. Thus, you're going to have natural log of y to be equal to cos x times natural log of 1 minus 3x. From here, we can differentiate both sides. So this side we're going to differentiate implicitly, and this side we're going to use the product rule, right? So to differentiate this implicitly, we're going to end up with y prime over y to be equal to so the derivative of cos x, that's negative sine x times natural log of 1 minus 3x, and then we are going to add cos x times the derivative of natural log 1 minus 3x, which is negative 3 divided by 1 minus 3x. So if we proceed, remember we said for natural log, so this idea is coming in because we said that natural log of u, if you differentiate this, you end up with the u prime over u, which is same as having 1 over u times du dx. So this idea is what we are using to get this thing here. Okay, so minus 3, which is the derivative of 1 minus 3x divided by the original function y minus 3x. So 1 minus 3x, that's why we're getting this as the derivative of natural log 1 minus 3x. So as we're proceeding, we're going to have 1 over y prime over y to be equal to, so this is simplest, we're going to have minus sine x minus sine x natural log of 1 minus 3x, then minus 3 cos 3x divided by cos x divided by 1 minus 3x. So that's what we're going to have. Then we're going to multiply by y, both sides, by y. So this one and this y will cancel, and here we're going to substitute our original function here, that's our y. Hence we're going to have y prime to be equal to, we can factorize the negative here, so we're going to end up with negative 1 minus, we're going to have sine x natural log 1 minus 3x, then minus, so we're going to have plus here because we have factorized this negative, so plus 3 cos x divided by 1 minus 3x, then times y, which will be 1 minus 1 minus 3x power cos x. This is the final result of this integral, of this derivative rather. So for the next example, we are given f of x being equal to 5 minus 3x squared raised to the 7th power, and the square root of whole 6x squared plus 8x minus 12. So we are proceeding to introduce natural logarithms both sides. So we're going to have the natural log of f of x being equal to the natural log of 5 minus 3x squared power 7, then square root of 6x squared plus 8x minus 12. So introduce the laws of logarithms. So we're proceeding with natural log of f of x. Here we're going to have 7 natural log of 5 minus 3x squared, then plus the natural log 1 over 2 natural log of 6x squared plus 8x minus 12. So why am I having 1 over 2 here? It's because this square root can be written as 6x squared plus 8x minus 12 raised to the half power. So if we will bring in the natural log, since there's a product here, we're going to have a plus. So after we put that plus here, this is the plus, and this is the power of this guy, the 1 over 2. So this is the closed form of this natural logarithm after we simplify. So when we differentiate this part, we're going to get f prime of x divided by f of x, as usual, is equal to, this we're going to have 7 times the derivative of this guy, which is negative 6x, divided by this whole function, 5 minus 3x squared, like that, plus 1 over 2. So we're starting with the derivative of the whole this thing is 12x, then plus 8. Then we're dividing this whole expression, 6x squared plus 8x minus 12, like that. Okay, so let's just simplify. Now from here, if we multiply this and this, you are going to get, if you multiply this and this, we're going to get negative 42x divided by 5 minus 7x squared. And if you do this other side, we're going to have plus. Now these two can go into these two numbers, so we're going to remain with this here, it's 6, and the 2 here is 4. So we're going to end up with 6x plus 4 divided by 6x squared plus 8x plus, no, this is negative, minus 12, something like that. Now from here, we just have to multiply by f of x. So if you multiply by f of x both sides, this and this will cancel, and you are remaining with something of this nature. So we're going to remain with f prime of x, which is the derivative that we're looking for, to be equal to, you can put f of x first, so that's what I'm going to do here. We're going to put 5 minus 3x squared, this raised to the 7th power, times the square root of whole a 6x squared plus 8x minus 12. Then I'm going to multiply with this thing here, so minus 42x divided by 5 minus 7x squared plus 6x plus 4 divided by 6x squared plus 8x minus 12. So this is the final result that we should find. Right, so the next example is differentiate y is equal to 2x minus e power 8x sine 2x with respect to x, where sine 2x is the power of 2x minus 8 of minus e power 8x. Alright, so we're going to differentiate that. So as usual, introduce natural logarithms both sides. So in the solution, we're going to start with the introducing natural logarithms both sides. So natural log of y is equal to natural log of 2x minus e power 8x times sine 2x. Applying the laws of indices and logarithms, we're going to get something of this nature. So sine 2x natural log of 2x minus e power 8x. Now we're going to use product rule this side. Here we're having y prime over y to be equal to, so the derivative of this guy will be 2 cos 2x using chain rule. You can verify that. And then this side we're going to have the derivative of the inner function, which will be 2. No, we're going to copy this first. Natural log 2x minus e power 8x, then plus. So we're going to start with the derivative of this guy, which is the following. So derivative of the inner function, so it will be 2 minus 8e power 8x divided by 2x minus e power 8x. Then we're going to multiply with this first function, sine 2x, something like that. Now if you simplify this, you're going to get the following thing. So after some simplification, you can find the following. So is equal to, so y prime over y is equal to 2 cos 2x, and natural log of 2x minus e power 8x, like this, then plus this and this can be combined into one numerator, so sine 2x multiplying 2 minus 8e power 8x, this whole thing divided by 2x minus e power 8x. Then you multiply by y both sides, so y prime is equal to 2 cos 2x natural log of 2x minus e power 8x plus sine 2x 2 minus 8e power 8x divided by 2x minus e power 8x, this whole thing times y, 2x minus e power 8x, this whole thing raised to the sine 2x's power. So this is the final result that you should get.